Okay, so this is the second part of solving systems of equations by elimination. This time we're using elimination with multiplication. So we're not starting with adding or subtracting. We're going to have to start by multiplication and then either add or subtract the equations together. Okay, so step one, you're going to have to multiply at least one equation by a constant to result in two equations that contain opposite terms. So you're going to have to multiply. And the key word that I want you guys to see there is at least. You may have to multiply each equation by a constant in order to get two equations that contain opposite terms. Now, what's a constant?
A number that does not have a variable.
Yeah, so a constant is a number that's by itself, okay? Once you do that and you rewrite them, step two is going to be just like what we did last week. So you're going to blank or blank the two equations together to eliminate it. You're going to add them or subtract them. So the rest of these steps you guys should know. What's step three going to be?
Multiply or divide.
No. We're already done with multiplying. That's just, nope.
Variable.
You guys, read the directions. Or read them.
Solve.
Solve. Thank you, Riley. Good Lord. That was rough. That was rough. Real rough. We're going to solve to get the value of the variable. Then we're going to plug the value into one of the original equations, and we're going to do what again?
Solve.
Solve. Then we're going to write our solution as an
Ordered expression.
Benjamin, you just be quiet over there. Ordered pair. Okay, so if you guys really pay attention to your notes, we're learning one new step. Everything else we did last week. So this one new step, that's going to be the only new thing that we do today. And you guys know how to multiply. So we all should be all right. Okay. So go ahead and write down example number 1.
Do I have to put it in line?
I would try to.
I honestly rather take a test every day than do the Okay, let's not give her an idea.
Okay, now.
Please take that idea.
When we eliminate using addition or subtraction, once we looked at our terms, we'd find where the coefficients were the same. Do I have a term with the same coefficient?
No.
No. So I can't just simply say, oh, I'm going to add or subtract these together to get rid of one of the terms. So that's where our step 1 in our notes come into play. We're going to multiply. You have to think. Now this is kind of the tricky part. So you're going to look at your two equations. You can either take one equation and multiply it by a consonant, or you can take an equation and multiply it by two different consonants to try to get one of these terms to end up with the same coefficient. So take a look. Would it be easier to get 5 and 2 to multiply by numbers to get to the same number, or 6 and 3? 6 and 3. Okay? Because if you use 6 and 3, can we multiply 3 by something to get to 6?
Yeah. You can multiply 3 by 6.
No. Don't do that. Can I take a number times 3 to get me to 6?
Oh, yeah.
What?
3
times 3 will get me to 9.
Oh.
2. So all I'm going to do is I'm going to take this bottom equation and I'm going to multiply it by 2. Now, the tricky part is you can do this in two ways. I'll show you the easy way first. So we're going to multiply by 2. So I'm going to rewrite my top equation just so they're lined up already. So I have 5x plus 6y equals -8. Okay? Now, when I say I'm going to multiply this bottom equation by 2, that means every term in this bottom equation I multiply by 2. So I'm going to take 2 times 2x and get 4x. Then I'm going to take 2 times positive 3y and get positive 6y. And then I'm going to take 2 times -5 and get -10. Okay, now I have terms where the coefficients are the same. Are you going to add or subtract these two equations to eliminate my 6y's? You're going to have to subtract. Okay? So 5x minus 4x is, or I could just put, okay? Then 6 minus 6 is 0, it eliminates. Then what's going to happen with negative 8 minus negative 10?
I feel like it would become positive too.
Okay, so two negatives. So it's basically negative 8 plus 10. What's negative 8 plus 10?
18.
No. Two negatives touching. This is a negative and this is a negative. Two negatives touching becomes a positive. So it would be negative 8 plus 10,
There's 2 negatives.
which would be positive 2. Your subtraction sign. Okay? Okay. It's kind of neat. You'll get it. You'll get it. Now, there's another way that we could do this. There's another way that we could do this. Could I use the negative 2? Could I use my constant as a negative 2 instead of a positive 2? Yeah. So like, let's say I just wanted to eliminate them for the beginning by adding. You do not have to write what I'm writing right here in the red, you guys. So let's say that you decided to use negative 2 down here to multiply it by. You would have got negative 4x minus 6y equals positive 10, right? Well, you would have ended up, if you added them together, you would have got the same thing. So 5x plus negative 4x, you still get 1x, so it's still 1. Then positive 6 plus negative 6 cancels each other out. Then negative 8 plus positive 10, you still got a positive 2. So it doesn't matter which constant, if you wanted to use 2 or negative 2, either one is okay to do, okay?
I'm confused a little bit.
I'll get you there. I'll get you there.
So how do you get the?
You'll have to wait. I'll show you. That's your new step, your step 1, multiply.
Yeah.
Okay, so we know x equals 2. So now, you guys know this next step. What do we do after we get what x equals?
Solve for y.
Solve for y. So which equation do you want to use? Does it matter?
I use 2x plus 3y.
Okay, so you want to do 2x plus 3y. So what do I substitute for?
X.
And I substitute a 2 in there.
Yeah.
Plus 3y equals negative 5. Okay, so I'm going to solve for y. What's 2 times 2 is 4 plus 3y. How do I get the y by itself?
Minus 4. You get 3y equals negative 9. 9 by 3. You get positive 4.
You get what?
Or positive 3.
Negative 9 divided by positive 3 is
Negative.
negative 3. So your answer is going to be,
2, comma, negative 3.
there you go. So we're only learning one new part. It's the very first step. Okay? Okay. Now, could you solve this equation by substitution? Yes. Could you solve this equation by graphing? Yes. Okay? So you can solve any of the systems by substitution, elimination, or by graphing. Okay, example number 2. So go ahead and write it down. Let's go into the right. Okay, so we're looking to solve this system by elimination. Our part 1 of this lesson last week was by addition and subtraction. But we had to have the same term with the coefficients the same in order to do that. Well, do I have the same terms or the same variables with the same coefficient? No. So that's where you're going to have step 1. So your first step, step 1, you're going to put multiplication there. Okay? So it says you're going to have to multiply at least one of the equations by a constant so that you get similar terms. Okay? So you're going to have to look at your variables. Leave those off. You're only looking at your variables. Which of these variables would be easier to eliminate? X's or Y's?
X.
X. what would be easier? What are we going to change our number to, our coefficient to? I'm going to change this 3. What do I want to get that 3 to? Yeah, so what can I multiply that 3 by in order to get it to a 6? A what? A 2. Now, if I multiply it by a 2, this is where it doesn't matter. This is a positive 6. If I multiply it by a positive 2, it's going to get me a positive 6, right? And then I'm going to have to end up subtracting for my elimination method. What if I made this a negative 2 from the beginning? Then I could just add them together. Does it matter which one you choose to do? No. So do you guys want to do a positive 2 or a negative? Negative? Let's do a negative. Okay. So I'm going to rewrite my top equation just so it's already done for me. 6x minus 2y equals 10. And then I'm going to multiply my bottom equation by the constant, negative 2. So negative 2 times 3x gets me negative 6x. Negative 2 times negative 7y equals positive 14y. And then don't forget, you also have to take that negative 2 times negative 19. So 2 negatives is going to equal a positive. So what's 2 times 19?
38.
38. Okay. So here's my system I'm going to solve. In order to get rid of the 6x minus 6x, am I going to add them or subtract them? Yeah. Okay. So 6x plus negative 6x, that cancels. Then what's negative 2y plus 14y? It's negative 2y plus 14y.
12.
Yeah, 12 what? Don't forget your variable.
12.
Okay. And then we just have 10 plus 38. Do you understand where I got that 10 plus 38? 48. Emily, you understand where I got that 10 plus 38?
Yeah.
Okay.
You divide by 12.
Yeah, and then you just divide by 12.
And you get 4.
And now we solve for
X.
x. Which equation do you want to use?
Oh.
Top or bottom?
Top.
Top. So what do I substitute for? What do I substitute for?
Y.
There we go. So 6x minus 2. There's my y. What do I put in there?
4.
4 equals 10. Okay? And now I just solve for x. So I have 6x minus 8 equals 10. Now what?
Plus 10. Or plus 8 or not.
Okay, now?
18.
And x is going to equal.
3.
So my solution is
3. 4.
what do you guys think?
I want to take a bite. Me too.
I don't like this.
I would like
As Xander says, my 3-year-old, too bad. Too bad, so sad. We're going to keep going. He does. It's so funny, you guys.
a cloud.
And he doesn't even use it correctly all the time, but when he does, it's awesome.
Oh my gosh, it's so like.
It's there, but it's still a little confusing, right? That's okay. It's a new lesson. I don't expect you guys to really catch on until the 4th example problem. All right, example number 3. Write it down. So what you're going to look at, you have your two equations. 9r plus q equals 13, and 3r plus 2q equals negative 4. Now we know when we eliminate, we need to find our terms that have the same coefficients. Well, that doesn't work here. So that's why we have to learn how to eliminate using multiplication as well. So then I'm going to have to look and think, what can I multiply either the top equation or maybe both equations in order to get the same coefficients? So, do I want to eliminate my r's or do I want to eliminate my q? Which one's going to be easier to multiply a number by, a constant by, to get those coefficients the same? And this one, honestly, guys, there's two easy ways to do it. So Ben might use one way, I might use another. Chance might think of one way where Riley's like, well, couldn't we do this? So there are two ways, there's multiple ways that you could actually use multiplication. So do you guys want to eliminate the r's or do you want to eliminate the q's? That's the first question you need to answer for yourself.
Q's.
Okay, so we're going to eliminate the q's. What do you think is going to be easier? Like what coefficient are we going to try to get the q's to both have so we can eliminate them? Huh? Well, what's this coefficient? 2. Can I get a 2q up there too as well? How could I get this to be a 2q?
Put a 2 in front.
Because we're going to, what's the whole point of this lesson? Elimination by what?
Multiplication.
So we're going to multiply this whole equation by 2. Now, real fast before I do that, you can either make it a positive 2 or a negative 2. Does not matter because then you're going to switch it at the end, but we can just keep it a positive 2 to keep it easy. Could I also have eliminated my r's? How could I have possibly chose to eliminate my r's? Look up here. If I wanted to get my r's and eliminate them, how could I have gotten this 3 to a 9? Okay, so that's what I'm saying. Emily could have chose to get rid of the r's. I could have chosen to get rid of the q's. At the end, our answers are still going to be the same. Okay, so we said we're going to multiply by 2. So 2 times 9r is 18r. Then what do I have?
2 times 9.
Right? 2 times 9r is 18r. Then 2 times q is 2q. And then I'm going to take 2 times 13 and get...
I didn't know you went over.
Yeah, you have to multiply every term in that equation by 2.
I'm not. I always look at 2q.
Okay.
Thinking you're multiplying 2q and 9.
Okay. No, remember we're multiplying by a constant, and a constant is a number that's by itself. And then my bottom equation stays the same. So I have 3r, well, I have plus 2q equals negative 4. Now, second step, am I going to add or subtract these equations to eliminate my 2's? Subtract. So I have 18r minus 3r, and that gets me,
15R.
I'm going to get there. You're absolutely right. And then as Madison, I'm renaming you today, Maddie. Your full name is now Madison. Is it Phil Madison?
It's Madeline.
Madeline. Yeah, I just butchered that. Said we're going to take 2q minus 2q, and those two are going to cancel or eliminate one another. And then we're going to come down to 26 minus negative 4. So what's 26 minus negative 4? What's going to happen to that minus negative 4? What's going to...
22.
It's going to... Nah.
Become a positive and become a positive.
Yeah, it's going to become a positive. So, Josh, you're basically looking at it like this. It's going to be 26 minus negative 4. Two negatives touch, and remember, it becomes a positive. Okay. And you guys should know what to do at this point, right? So what's my r going to equal?
2. Now, real quick question.
Yeah.
So when we're putting down the comma stuff, does the one that has to be closest get put in front for X? Or?
ABC order. So the one that comes first in the alphabet goes first. That's an excellent question. Okay. Now, we're going to solve for Q by substituting for R.
Wait, that's not
Top one.
alphabetical order.
Not yet, it's not. You're going to use the top one, you said?
Yep.
So we're going to have
Q is X.
9R Oh, what do I put in for R?
2.
Plus Q equals 13. Okay?
18 plus Q equals 13 minus 18 on both sides.
So then Q is going to equal.
-5.
Now, we're going to put them in alphabetical order. And I think, Dylan, was it you said that Q represents X?
No, I said so.
Was that Josh? Josh is like, I am taking that credit, Ms. Littleton. That was me.
It's bonus points.
So Q is -5 and R, my Y is 2. So that was example number 3. Okay. So by the 4th example, you guys should be feeling a little bit better about this. A little more confident. And I said the 4th example you guys should get by yourself, right? You should be able to get by yourself. Why did we pick 2? Because we decided we wanted to eliminate the Q's, right?
So if I wanted to go with the R's, I should pick 3.
Mm-hmm. And you would have multiplied by this bottom one.
Alright, so I'm confused. So how do you get 26 minus 4? That's not 30. That's
26 minus -4.
2 minus equal.
Remember, 2 negatives touching or negative and a subtraction sign equals a positive.
Can I have one?
So if you type that into your calculator, 26 minus -4.
That's tricky, right?
Did I answer your question there? Okay.
Can I have multiplied by 9 then?
You could, which one?
Because you said you picked 2 cubes because you eliminated
So,
cubes.
where do you want to multiply by 9?
I'm asking.
So if you want to multiply by 9,
No, it doesn't matter which number I pick.
it does because you want to be able to end up getting the same. Do you see how I multiply by 2 to get my 2 Q's so they have the same coefficient so I can eliminate them? You have to pick a number or numbers, a consonant, that you can multiply to get your coefficients the same so you can eliminate that variable. Okay? These are all really good questions, you guys. You could have put -2, and then we wouldn't have had to subtract the equations. What would we have had to do if we used -2? Instead of subtracting, we would have added them. Now, when I did my notes, I used negative constants to make it easier because I'd rather add equations together than subtract them. But that's your personal preference. Okay, now, I said example number 4 you should be able to do on your own. However, that's not 100% accurate because example number 4, remember if you reflect back into our first part of our notes where it says you're going to have to multiply at least one equation by one constant? Guess what we're going to do for this example? Yeah, we're going to multiply both. Okay? Now, when we multiply both, more than likely you're not going to multiply each equation by the same constant. Okay? So, take a look. You need to pick which variable do you want to eliminate. Do you want to eliminate x's or y's?
Definitely.
It doesn't matter. X's or y's? Okay, so Chance spoke up first, so we're going to go Chance way. We're going to eliminate the y's. Now, we have to get the y's so that they have the same coefficient. What's the easiest way to get where 2 and 3 are going to have the same coefficient? What number, if you count multiples, what number do they share? 6. Awesome. So, what times 2 will get me to 6? Okay, so that's what we're multiplying our top by. So our constant that we're going to multiply our top equation by, as Chance said, it's going to be 3. Because that will get me to 6. Okay, we're eliminating y's. What am I going to have to multiply this 3y to get it to be a 6? 2. Now, if I multiply it by a positive 2, we're going to have to subtract our equations. If I make it a negative 2, I can add my equations. Again, it doesn't matter. Which would you guys rather do? Make it a negative 2 or a positive 2? You want to keep it as a positive? Okay.
I just picked random.
Okay, we'll make it a negative next time. So here we go. So let's go ahead and multiply our top equation. So every term in this equation we multiply by 3. Okay? So 3 times 4x is 12x. 3 times positive 2y is positive 6y. equals, and then 3 times 8. What's 3 times 8?
25.
How about 24? Okay. Now we come down to our bottom. We have, you guys decided that we're going to use the constant 2 to multiply each term by in order to eliminate our y's. So we're going to take 2 times 3x and get
6x,
then 2 times positive 3y,
6y,
and then 2 times 9.
equals 18.
Okay. Now, in order to eliminate my plus 6y, so my 6y plus 6y, how am I going to eliminate those?
Minus.
So I'm going to have to minus these 2 equations to eliminate that. Hello. We're right in the middle of a new lesson. Okay, we'll do. Bye. That's a really ugly 18.
Is that for me?
Yeah, at the end of the hour.
Who?
Ackerman. Okay. So you guys already said we're subtracting. So 12x minus 6x. What's 12x minus 6x?
6x,
Okay. 6 minus 6.
cancel.
Eliminate. And then we have 24 minus 18. What is that?
8,
What is it?
wait. I was looking at the wrong one. It is 6.
How much you want to bet Miss Scott?
Negative 6 or positive 6? Positive 6. Okay.
Has to be.
Focus on this for now, and we'll determine the rest of that later. How do I get the x by itself?
Divide by 6.
Don't you guys like this part of the problem? You're like, yeah, I got this. Okay. And then now we need to find what y equals. So we substitute for x. Doesn't matter which equation you want to use, just pick one.
First.
First one? Okay. So we have 4. I'm going to substitute for x. Okay. 4 times 1 is 4 plus 2y equals 8.
Minus 4 on both
Ooh.
sides.
I got to redo that 8. Okay, minus 4 on both sides. 2y equals 4. Divide by 2, and as Chance just said, y is going to equal 2. So my solution is
1, 2.
1 comma 2, parentheses around it. There we go. Okay.
Wait, I think the hour, I think the lesson.
What's that?
We only have 3 minutes.
No, we don't. We get out 9:55.
That's it.
10. No, I lied. What time do we get out? Oh my gosh, we got out 10:50. We do only have 3 minutes. We're going to stop there.
Can you